Hey everyone, and welcome. Today we're going to jump right into Chapter 1, Chemical Reactions and Equations. This is a super focused revision to help you absolutely nail your board exams. So let's get started.
Okay, first things first, don't panic. I know this chapter can seem a little tricky, but trust me, it's not that hard. We're gonna go through it together, and I promise you, scoring full marks is totally doable. Seriously, इसके बाद chapter easy लगेगा. So, we're gonna start with the absolute basics. You know, if you get this foundation right, the rest of the chapter becomes super easy. So what's the big difference here? Take a look at the left side. When ice melts, it's a physical change. It's still water, right? Just in a different form. But now shift your eyes to the right. When you burn wood, it turns into ash and smoke. That's a completely new substance. And that is a chemical change. Simple as that.
Okay, so how do we actually write all this down? We use a chemical equation. And it's actually really simple. The things you start with, you can see them on the left, are called reactants. And all the new stuff you end up with on the right, those are your products. So reactants become products. That's all there is to it.
All right, now this is the golden rule. And you really need to listen up here because this is where most students make a common mistake and lose marks. You have to always balance your equations. So why do we do this? Well, it's because of a really important law. Atoms can't just be created or destroyed. You can't just poof, make atoms disappear, right? So the number of atoms you start with on the left has to be the exact same as the number you end with on the right. Okay, let's get into the different types of reactions. A good way to think about them is like simple stories. Sometimes things join together and other times they break apart.
So first up, we've got the combination reaction. I like to call this the chemical marriage. It's pretty straightforward. Just look at the slide. You have A and B. They come together and they form one single thing, AB. Two or more reactants making one single product. That's a combination reaction.
Okay, pay close attention here, because this one is a huge favorite in exams. They love asking about what you actually see happening. So the points that will get you marks are right there in step 2 and step 3. It burns with a dazzling white flame, and it forms a white powder. Remember those two phrases. That's an easy 1 or 2 marks right there. And next, we have the total opposite, the decomposition reaction. I call it the breakup. One single compound, AB, splits apart into simpler things, A and B. And just like a real breakup, it takes energy, right? So these reactions usually need some heat, light, or electricity to get going. Now this table right here, this is pure gold for your exam. Let's look at that first row. Ferrous sulfate starts off green, and when you heat it, it turns reddish-brown. Now the second one, lead nitrate, which is white, gives off these very obvious brown fumes. The exam will ask you directly, what is that brown gas? And the answer is nitrogen dioxide, NO2. You have to memorize these colors.
Another really important type of decomposition is the electrolysis of water. Basically, you pass electricity through water, and it splits into hydrogen and oxygen. The key thing to remember, the part they always ask about, is the ratio. You always get twice as much hydrogen as you get oxygen. And why 2 is to 1? Well, just think about the formula for water. It's H2O. 2 hydrogens for every 1 oxygen. That's where the 2 to 1 ratio comes from.
All right, moving on to section 3, which is all about swapping elements around. You can kind of think of it like a game of musical chairs, but for atoms.
First up, we've got the displacement reaction. This is what I call the bully reaction. So what's going on here? A more reactive, sort of stronger element comes along and just kicks a less reactive, weaker element out of its spot. It's all about who's higher up in the reactivity series.
And here it is, the classic experiment that pops up on exams all the time. So you take an iron nail and you stick it in a blue solution of copper sulfate. Now, iron is the bully here. It's more reactive than copper. So what happens? 2 things. You got to remember these. First, the blue color of the solution starts to fade and turn a pale green. And second, you'll see a brown coating forming on the nail. Those 2 observations are your key to getting full marks.
Next is the double displacement reaction. This one's not a bully situation. It's more like a partner swap. As you can see, 2 different compounds just switch partners. Their positive and negative ions trade places. A lot of the time, this creates something called a precipitate, which is basically just a solid that suddenly appears and sinks to the bottom. It can't dissolve.
Look, for your exams, you only really need to know these 2 reactions. Focus on this table. You mix sodium sulfate and barium chloride, you get a white precipitate. You mix lead nitrate and potassium iodide, you get a bright yellow precipitate. Remember, barium sulfate is white,
Lead iodide is yellow. Lock that in.
All right, we're in the home stretch now. Let's quickly talk about redox reactions and then see how all this chemistry actually shows up in our daily lives. Okay, redox. The name sounds kind of complicated, right? But it's not. It's just two things happening at the same time: oxidation and reduction. So what are they? As the slide shows, oxidation is when you gain oxygen or lose hydrogen. And reduction is, well, it's the exact opposite. You lose oxygen or gain hydrogen. Here's a little trick. Just focus on remembering one of them. The other one is just the reverse.
So where do you see this in real life? Corrosion. It's all around us. You know, the reddish-brown rust on iron? That's oxidation. The black stuff that forms on old silver jewelry? Oxidation. And that green layer you see on old copper statues? Yep, you guessed it, oxidation. These are perfect examples to use in your exam.
And another everyday example? Rancidity. You know that awful smell from a bag of chips that's been open for too long? That's the oil in the chips getting oxidized. So what do the chip companies do? They're smart. They pump the bags full of nitrogen gas, which is super unreactive. It basically creates a protective shield against oxygen, keeping the chips fresh.
Okay, so we've gone through the whole chapter. But now for the most important part. This is your final exam cheat sheet. Everything you need for a last-minute revision is right here. Okay, everyone, eyes on the screen. This slide is your secret weapon. It has every single important color change that you need to know for this chapter. Green to reddish brown, white powder to brown fumes, blue solution to pale green. Seriously, pause and take a screenshot of this right now. This table is going to save you so many marks on those observation questions.
All right, time for a quick quiz to see if you were paying attention. Looking at our cheat sheet, what is the color of that precipitate you get when lead nitrate reacts with potassium iodide? Let me know your answer in the comments below. You've got this. I really hope this quick revision helped. All the very best for your exams.